I hope now it should be okay. Can you hear me?
Yes, sir.
Okay.
It's visual, sir.
Okay. So today's my topic is sustainable soil and organic matter management uh, for reducing straw burning, greenhouse gas production, and the influence factors in Northwest India. But this is my second half to collaborate with lovely professional university in Punjab. But the first half is more focused in the southern part of India, Tamil Nadu. So anyway, this project is supported by the Akash project. As a member is listed here in the different institutes, Japan, and also the international organization. So my highlight is already mentioned as a member, honorary National Academy of the Agricultural Science in India. Just for last year, especially the topic is focusing on the reducing straw burning for healthy life and sustainable agriculture. I was awarded the last year together with ED DGG, Deputy Director General, and ICRISAT, former Director General. I was very honored to be there. And also I'm advisory board of South Asian Research Center in the Bangalore since 2019. Less activity during COVID-19, but I should be activated for the next session. Okay, let me move on to the background of the today topic is climate change and global warming. As you may know, global temperature increase year by year, although the fluctuation, but the long trend is constantly increased like this. And most of you are knowing about greenhouse gas, especially carbon dioxide, CO2. But that is not all. The rest is about the methane and nitrous oxide. And the CO2, not only from the fossil fuel, but also the destruction of soil management, like deforestation or desertification. So the CO2 is not only for fossil fuel, but also the soil-related matter. I'm sorry in Japanese, but I will translate one by one. In case of the global contribution of methane in this pie diagram, paddy is about 10%, just next to the livestock. And also natural wetland, as indicated as green part, is also some contribution. So not only human activity, anthropogenic methane, but also natural methane is also a problem. But in the last century, this contribution become bigger and bigger. That's why that we should find the best way to control the greenhouse gas methane emission from paddy field, especially this case. So you may know very well about rice cropping system is quite diverse. Main area is lowland single or double rice cropping system, like the shallow water, controllable water, all the way of the cropping season. But also we have some deep water, wetland, the rice, like more than 1 meter in the depths of the water, just flooded. Or in the opposite side is upland rice. But this extreme situation, the crop productivity is not stable. So we are focusing on this lowland single or double rice cropping system. So that there are some the problem. Also, acid soil, pest, drought, or low input. Maybe contributing to the low yield and low income. So we should take over the sufficient water or higher income, how to control the water and also crop rotation, important. The rice cropping, not necessarily rice and rice, but also rice wheat is also very important, especially India. So that's why that we have quite diverse system of crop production. In Japan, for example, most of area, more than 90%, is single rice. The rice is very limited, only the 6%. But in the world, irrigated rice is just over half. We have also rain-fed, about 30%, or upland rice, especially Africa or Central South America. It's a very important rice cropping system. So we have quite different type of the rice cropping in the world. So we should be careful. Rice is not necessary to be flooded. Sometimes upland, sometimes rain-fed. However, the crop production is much less to compare with irrigated. When the soil is irrigated, the soil fertility is increasing because of nitrogen fixation or organic matter the remaining much more than the aerobic system. However, to compare with aerobic system, anaerobic system may be good for the methanogens, microorganisms, to create methane as a greenhouse gas. So the controlling water or rice variety, fertilizer, and organic matter, etc., should be very important key factor to control methane from paddy field. We remember rice crop system is man-made ecosystem, not natural ecosystem. So we know the best way how to control the methane from flooded water. But if there might be mismanagement, many methane is coming out. For example, if you apply the fresh rice straw, this is a huge amount of methane coming out. Methane itself is not toxic for the human and not toxic for the rice, but intermediate product for the methanogens, like the organic acid, may be toxic for rice. So that where the rice emitted a lot of methane, maybe fertility is not so good. So that we have some correlation between the methane production and soil property. If we can drain the field, methane can be minimized. However, organic matter may change for the source of CO2, obviously, as a carbon source, but also nitrous oxide changing from the nitrogen fertilizer or inorganic nitrogen. If you consider global warming potential, GWP, as a CO2 mole 1 is equivalent to the 21 times of the methane and over 300 times stronger in case of nitrous oxide. So if we miss nitrous oxide emission, that could be a serious problem, not only for the CO2, but also the methane and so on. So I will show you the more detailed calculation later. But in this figure, soil fertility should be harmonized with microbial activity in case of greenhouse gas production, like these bacteria and other microorganisms. We know how to control their activity, like water management or organic matter management. So please remember, the rice ecosystem is man-made ecosystem. So if we know the good way to control the methane, we can make it sustainable rice cropping system possible. So this is the dynamic of the paddy field. The rice is grown under flooded water, and rice root may be contribute to the organic matter substrate through the dead root or plant debris. And that organic matter can be utilized by microbes such as methanogens to make it soluble carbon and CO2. And finally, soluble methane can be emitted through rice plant to the atmosphere. So the even fix CO2 to the green biomass, some part might be emitted as a methane, 20 times stronger than CO2 in this case. But if we control soil organic matter management or water management to introduce oxygen, we can stop some methane emission by another microorganisms, methane oxidizing bacteria. The result would be CO2 as a final product, which is 1/20 times weaker than the CO2. So the CO2 itself can be cycling if we can utilize the methane oxidation effectively. However, methane itself is very easy to emit through rice plant. The activity of methane trough is very tiny amount and can be utilized only the part of methane. The remaining part may be emitted as methane to the atmosphere. So if we can stimulate the activity of methane trough, that could be possible in the future for reducing methane. That can be the one dream for the future. So let's go back to the Haryana, the rice wheat system. We have a chance to observe the rice wheat cropping system in northern India. During the wheat system, the pH is a little bit alkaline and higher the effective conductivity. And taking this soil into the various cropping system, like I showed the continuous flooding or the aerobic, anaerobic crop rotation to assess the greenhouse gas emission and controlling soil fertility and environment issue can be balanced to be harmonized for sustainable agriculture. That is our dream. Okay. So we can compare rice soil in Japan and India to be analyzed for the biochemical properties and greenhouse gas production and evaluate the best management for sustainable use. So microbial analysis, soil biochemical analysis can be achieved by measuring soil pH, EC, electric conductivity, total carbon, organic nitrogen, mineral nitrogen, CEC, soluble organic carbon, microbial biomass, and so on. That could be some basic, some are bit advanced technique to measure the microbial biomass, for example. But anyway, it's not too high the technique. So you can try. So this is the scenery just after Christmas 10 years ago to see the soil sampling there. Then taking the soil sample, bring back to the laboratory to put in the bottle and incubated either aerobic or anaerobic by flooding water, incubated to simulate the rice cropping system for the 30 degree and the upland crop to 25 degrees. And several periods later, we can take the gas sample from the head space of this bottle, then inject into the gas chromatography to assess the CO2, methane, and nitrous oxide by using the different the detector, TCD, FID, or ECD. So incubation setup is somehow like this one. Then after incubation, we can also measure the mineral nitrogen by extracting like this. For Japanese soil, we just set up soil only as a control or with rice straw as RS, aerobic for 2 weeks, then flooded for 3 weeks. For India and Uganda, just you can forget it, but India soil only because sample is limited at that time. So we can compare the rice straw only in the case of Japanese soil. Anyway, this is a method. Here is a result for rice with the soil in Karnal in India. You can see CO2 is dominant by aerobic incubation, as indicated in the red color, independent of the application rate. To compare with blue line, flooded condition. However, in the middle, in the methane, CH4, obviously flooded system has more favorable for production of methane to compare with aerobic. In case of nitrous oxide, bit similar to the CO2, aerobic system is more favorable for the nitrous oxide emission. So we should be careful the condition of the soil to decide which greenhouse may be emitted during the incubation. So rice cultivation, we should be careful for methane. But wheat cultivation, we should be careful for both CO2 and nitrous oxide. But this is just as an extreme situation for aerobic or flooded. In the field, somehow the intermediate condition might be also existed. So I will show you more detail in the field situation. So let me move on to the South India, Tamil Nadu. So the Tamil Nadu, sometimes possible for the triple crop, and also the important straw management. And that might be a source of the air pollution sometime after the straw burning. Tamil Nadu Rice Research Institute and the Tamil Nadu Agriculture University is a key station for the Kumbakonam in the lowland, Adutrai, and also Tanjavur for the little bit plant field in the Soil and Water Management Research Institute. We took the soil sample 5 years later, and we visited like this situation. And we have some MOU exchange with the dean and project leader with Professor Ayashida, and also Dr. Sudo and other teams, and new project leader. I will explain later.
Professor Inubushi, I'm just disturbing you. Can you
Yes.
just speak a little louder, or can you hold your mic little nearby, because the sound is very less.
Okay, sorry.
Yeah, right
Now
now it is clean.
okay.
Right now it is clean.
Okay. Sorry. By the way, if you have a question in the chat, I will reply if possible. And I may stop after the Tamil Nadu case study to separate into 2 parts. So if your question, or maybe you can just send it to the chat box. I'm very happy to make some short discussion after Tamil Nadu. Is that okay? Okay, let me continue. So in case of Tamil Nadu paddy field, we set up the chamber in the field by using also platform to avoid the disturbance, the, to avoid the step into the paddy field. Because once you step into the paddy field, there are a lot of the disturbance to make it to the artificial bubble for the methane comes out. So we should be very careful to walk on the platform, and please be careful to put the cover we call the chamber for measuring. But during the covering chamber is maximum the 1 hour or even less than half an hour, just to stop the emission into the atmosphere. We can keep some gas inside the chamber. That is very basic static chamber method. So you can try. And in this field study, we tried the SRI, system of rise intensification, which can reduce methane emission from paddy field, they said. So we are trying to make it. And also important, one factor will be also the nitrous oxide. Nitrous oxide may be trade-off. Trade-off means we are trying to reduce the methane, but sometimes nitrous oxide coming out. So this may be very complicated system in the paddy field. The target is not only the single target for the methane, but also don't forget nitrous oxide, especially during the unflooded period. But to make it short, we need not to worry too much for nitrous oxide. So the water saving is effective to reduce methane up to 40%, like this one, to compare with control or check that we can reduce SRI, the methane is about half. And nitrous oxide, no significant difference between the water control treatment. And GWP, as I mentioned, we can calculate to sum up two gases into CO2 equivalent. So as a total, still the global warming potential CO2 equivalent can be reduced. So nitrous oxide, in this case, don't worry too much. So we can control, we can focusing on the methane in the paddy field. That is the situation. We tried two different varieties, and also we tried over 2 years experiment. And the research paper is already published, and you can check if you want. And another important point is yield, productivity. No significant difference among the water treatment. So if we have carefully control the methane, so that could be also the sustainable and acceptable for the farmer. Win-win situation can be possible. Another high-tech is micro-meteorological method to set up the flux tower like this one. And there is a sensor for the CO2, methane, and also nitrous oxide. This picture is not included for nitrous oxide, but the methane and CO2 and the vapor can be monitored 24 hours every day and over the whole crop of the rice growing without disturbing. Another important point is field scale, like this scale, not necessarily small chamber to cover the crop. So on the other hand, you cannot set up the detailed treatment. So we need the whole uniform field for the representative data of this flux tower. Anyway, this has also the rather high-tech the instrument required. So not every station can make it. However, if you can measure the water level, also the soil temperature and moisture, together with the gas data, we have the beautiful the data set for the measurement. Another the technique to control the water, not by man-made, but also the robot, automated water control system, now become popular in Japan.
Professor Chandra, Professor Inobushi,
Yes.
I'm interrupting you. Will you try one thing, like without your microphone, will you speak for a second, like so that we can understand like which voice is clear, much clear?
Oh, I don't know.
Because the sound is very less, like everybody is like messaging, like sound is less. So if you are giving from your laptop, you can directly talk it. Can you check once which one is loud
Okay.
without microphone? So is it without microphone?
Yes, this is now.
It is fully clear.
Is that clear?
It is fully audible, sir.
Okay,
So you
but
can continue
in
like
my
that.
side, your
Yeah.
voice is very small.
Okay. So it is now clear, sir. You can do one thing when the questions will be asked, you can
Okay.
take your mic, right?
Okay.
Right
Thank
now
you.
it is much better. Everybody will be listening, I think. Sorry for
Thank,
this.
thank you, Barney. My poor instrument.
No issue, no issue.
But this picture shows you some self-stand with the solar battery and connecting to the water pump regulator together with water sensor to open and close the irrigation water from the main channel for the individual field. They are controllable for without the human activity. It's self-stand and automatic control. Now that you can set up not only this field, but the next field, next field, all the connecting to the main channel. You can just set up the automatic water control system in the inlet of the paddy field. This is still the experimental scale in the University of Tokyo, but you can try if you have interest. Just additional information, we have also low-tech against bird attack. This is? This is a kite, but a model kite, and shape is like the hawk or maybe the the big bird. That is also very effective. Not only the nest, but also the bird attack may be significantly reduced. I think India is already available like this system, but it's very low cost. Anyway, so back to the Tamil Nadu, we have also the straw collection in the February, and also the director helping us in the two stations, not only but also Tanjabur. If you leave the straw in the field, sometimes there are built up the straw, and somehow no way to avoid, then start burning. So that is serious problem, not only Punjab, Haryana, but also Tamil Nadu. That could be also big the initiation for the next project. But anyway, straw management is also important. If you can make it to the farmyard manure, we can stop the reduction of the nitrogen fertility, soil fertility, year by year, over 10 years or 20 years, in both Indian case and also Nepal case. So this is obvious. If you keep only the chemical fertilizer, decline of soil fertility is very significant. But in case of the farmyard manure or sometimes green manure like Sesbania, you can maintain the soil fertility over the long range. So the straw maybe the source of the farmyard manure or good green manure can help the sustainable soil fertility. So this is somehow against the green revolution. We should go back to the traditional agriculture. But now it's quite modernized, and chemical fertilizer also sometimes price is going up. So that would be another critical issue for the sustainability of soil fertility. So the biochar may be another solution. So how to make it the straw to be sustainable for the rice productivity. Sorry again in Japanese, but the biochar have some suitable property, especially the total carbon and total nitrogen. And somehow the condition is like this one. Important factor is soil carbon storage as a sequestration of atmospheric CO2 into the soil, improving physical chemical properties of soil, and also reduce greenhouse gas, as some literature said. But we need some more experience. So biochar sometimes reduce methane productivity, but sometimes the opposite, as a nitrous oxide coming out. So this is another introduction for the next project. But maybe I may stop somehow for the first half. If you have a question, I'll be happy to answer your question, especially in the chat box. And there are several questions.
Sir, I think one of the question is, sir,
Yes.
one of the participant has asked Nila Kotrai. He has asked rice has a C3 photosynthetic pathway. In Tamil
Yeah.
Nadu Agriculture University, there has
Yeah.
been research regarding converting the C3 to C4 photosynthetic pathway. Is this useful, sir? What's your opinion in that?
C3 plant, yes, actually the rice plant has a C3 photosynthetic pathway. But so far we have no C4 rice plant at this moment. But if you can utilize the photosynthetic activity to C4 more effectively, we can reduce somehow the carbon leak during the photosynthetic to make the more the methane as a leakage. So I think that's a good idea to try to make it C4 photosynthetic utilization for the rice production. But so far, we have not yet successful the candidate for that one.
Sir,
Is that-
another question is there,
Yeah.
like from Sanjana. She is asking how we can reduce the GHG emission. What is the best way?
How to reduce?
GHG, sir, greenhouse gas emission.
In total.
Yeah.
Yes.
How to reduce?
Somehow the trade-off, if we try to emphasize the reduction of the methane, CH4 only, sometimes the trade-off to make it nitrous oxide coming out. So we should be careful to make it the trade-off effect of CH4 and N2O. But also the CO2 itself may be another problem. But if we carefully manage water level, for example, how much the water can be reduced, so that sometime AWD, alternate wet and dry technique recommended by International Rice Research Institute in the Philippines, they said minus 20 centimeter is the maximum possible reduction of the water level to make it harmonize of the methane reduction and not increase the nitrous oxide. So, but that minus 20 centimeter is not universal, the standard. We should be careful to check in different soil type or different crop system. Is that okay to answer your question?
Yeah, sir. Yeah, sir. And another question is there, sir. How
Yeah,
SRI is able to produce less methane than other cultivation method? SRI
yeah,
means system of rice intensification method. How it is minimize the gas emission?
yeah. SRI is one of the possibility, not only the greenhouse gas, but also the water saving technique. So that could be a good question. What is the best the management for not only the greenhouse gas, but also the productivity, sometimes water saving, and also sometimes weed problem might be coming out. And also, we should be careful about labor, the cost. For example, the automatic the water control system, maybe one of the candidate as a modern technique, like I'll show you in the case of Tokyo University Agriculture field. So that is many options to find the best way. And but not only one method, because we have not only one agricultural system in the world. We have many quite diverse cropping system. So we should try to adapt the best way for each the cropping system. Is that okay?
Yeah, sir. So I think you
Okay.
can continue with your lecture, sir. We will take the questions later on.
Okay, okay. So is that voice is still okay?
Yeah, without
Okay.
mic, it is much clear, full clear.
Sorry, I didn't realize, but now no family. This time it's already 11 p.m. in Japan, so that is possible.
Yeah.
Okay, so let me continue. Second half is a biochar and also the Tamil Nadu. Moving from Tamil Nadu to Punjab. So we have set up another experimental field in Tamil Nadu also by using the different two types of soil with or without nitrogen fertilizer and soil only, soil rice straw, soil plus biochar, or soil plus rice straw plus biochar, and 3 replicate for the incubation setup as I showed you before, anaerobic incubation for 8 weeks. Then each buyer was using 10 grams soil and so on and so forth. Then nitrogen addition is equivalent to 10 kg nitrogen per 10 R. So the setup is somehow like this one. Again, we have 2 weeks the preliminary the aerobic the system to simulate the wheat cultivation for other vegetable cultivation. And after that, we applied again the nitrogen fertilizer and with or without biochar amendment. 1 week, 4 week, and 8 weeks later, we can just take out the headspace gas. We have also additional longer experiment also. So here is just the summary of the result. As I said, CO2 equivalent calculated as the sum of 3 gas in the 1 bar, but the methane as indicated as green. And in Tamil Nadu Rice Research Institute, even with or without nitrogen, methane blue bar is not dominant to compare with the CO2. CO2 is dominant. Nitrous oxide in the top is still minor. But in case of soil and water in the Tamil Nadu, this is a bit sandy soil. So the more methane is coming out if we consider the global warming potential like this one. Especially if we apply the nitrogen fertilizer, somehow the methane is coming out. So that is quite interesting. So we should evaluate all over the incubation system in the CO2 equivalent. So somehow the statistical significance might be possible if we consider nitrous oxide is very high. So nitrous oxide was negligible in this case because you cannot see the gray bar invisible, even with nitrogen. Because this is a flooded system, so nitrous oxide is very limited in case of flooded situation. So that is the Tamil Nadu conclusion. Soil type significantly influence methane production because of their iron content. As I forgot to mention, the dry soil has a higher iron content. So this can reduce the methane production. While methane CO2 is affected by organic matter amendment. Rice straw increase both methane and CO2, while additional biochar decrease the methane production, but not influence for the. This second point is important. Let me just move back. So in case of the biochar, here is SB to compare with SR, the significant reduction. Also this situation, all situation, biochar significantly reduced to compare with fresh rice straw. So that is important message. Biochar may be possible candidate to reduce methane production, but CO2 is not changing. So there is no clear tendency for the influence of soil water on nitrous oxide. Nitrous oxide may be negligible in this case study. So let me move on to the Punjab. The Punjab problem is not only the biochar, but also straw burning. So I will explain Punjab, but you know Punjab very well. So I will just briefly skip the information. But let me emphasize a new India-Japan project named Akash project. So that is not only single soil scientist or agronomy, but also remote sensing or the atmospheric chemistry or even the human health assessment is possible to avoid the straw burning. The examination of alternative option for straw burning is target for one group, working group 1, which I belong. The effect of biochar on the soil and greenhouse gas, as I showed in the Tamil Nadu, we have also set up the field experiment in Punjab. So the background of straw burning, it's not only the Tamil Nadu, but also Punjab more seriously, and also sometimes more critical, especially if you think about the global scale. The fire hot spot is all over the world to make it straw burning or biomass burning. In the Amazon, not only the agriculture, but the forest also critical source for the biomass burning. And case of the human health somehow exceed PM 2.5. So the CO2 methane is greenhouse gas, but sometimes CO, carbon monoxide, or other nitrogen gases combine together to make it to a particle less than 2.5 micrometer. Serious problem all over the world, but especially India and China. Serious problem, especially biomass burning, as statistically saying. So agriculture waste is one of the critical point for agriculture related. Savanna or forest will be also the serious problem. But we are now focusing on anthropogenic mass burning, especially the agriculture. We need somehow estimate of the carbon flow from the agriculture. If we consider in Japan, the sorry in Japanese, but the rice straw is only less than the total amount of Punjab. So Japan is a small country, but also the rice straw is somehow shortage. Sometimes we need to import for the feed for animal. But in case of India, Punjab and Haryana is a very big source of the residue burning, total in the 30 megaton, which is easily over Japanese number. Punjab, you know very well, close to the border to Pakistan, and rich in the water supply from the mountain region. But the total area is bigger, and also another important is criticize the smoke flow towards the capital city in Delhi. A lot of the smoke is coming from Punjab. Actually, the Pakistan Punjab or even the deeper area is the source, maybe from the satellite image. We have also some hotspot data. The Pakistan Punjab is not so big hotspot, but over the border to India, a lot of hotspot in the satellite image. And you can just shifting this image like this one. So you can see the overlap of the smoke somehow coming from Punjab. But sometimes Punjab smoke is going the other side. It depends on the wind direction. This is the mountain ridge and the Himalaya. So that is a block by this mountain. The air is moving this way or this way only. And if you come out, New Delhi has a serious air pollution, maybe the end of October until the early November, just like the rice harvesting season. So why the rice harvesting season? Because water shortage delayed the transplanting time from June to late June. After the water action in 2009, we cannot transplanting before that one. That's why the harvesting time the delayed and very short before the wheat seeding, narrow window. That's why this becomes a more stable burning in very short period, and later the cause smoke. Another problem is by using the big combined harvesting machine, a lot of the biomass remain in the field and not easy to incorporate it in the soil. So that's why the farmer tended to start burning. Of course, they are controlling partially, but not perfectly. So that is criticized not only the local, but also in the global issues. So we started the international collaboration work with the Indian side. Initially, the leader is Professor Hayashida. Later, we changed to Patraplavir after last year. This is also the clean air, public health, and sustainable agriculture. The three targets are established, harmonized, how to avoid slow burning, how to utilize crop residue more effectively. So I belong to the working group 1 for sustainable agriculture, including agroeconomics, human geography, cultural anthropology, and agricultural scientists. To work with working group for the clean air and working group 3 for the public health. And the common target is behavior changing, shifting from strong burning to make it more sustainable the ecosystem. And we can also working together not only agriculture, but to stakeholders and government. So in the working group 2, they are using the satellite image, and working group 3, for example, the individuals air monitor to check the people's behavior and also the public health. But as I'm not expert for the working group 2 and 3, I should focus on the working group 1 for especially working with lovely professional university to utilize the biochar to reduce greenhouse gas and also the establishing the sustainable crop system. And another experiment too, this is a two, sorry. Number 1 is array cropping system, like in this picture, to utilize the how do you say, not only the monoculture, but also mixed together with vegetables or citrus or the crop culture for the sustainable alternative single rice wheat system. So let me focus on the biochar experiment like this one, how to utilize the biochar like this one. As I mentioned, to achieve the climate, the take over the alternative climate change, improve soil health, enhance crop diversity, increasing soil carbon. So biochar would be very important as this one, merit carbon sequestration. But also, as I mentioned in Tamil Nadu, nitrous oxide may be another issue. Not only the carbon balance, but also nitrogen balance should be also carefully, as well as the nitrogen leaching. So we visited many times already in the Punjab, and also Mr. Bani started to help the field measurement like this one, and also crop harvesting like this one. Sometimes we have stem borer for the crop damage, and sometimes we do some soil sampling, and sometimes we have to be careful about the water moisture to avoid the plant damage by applying the biochar. But also the soil chemistry, pH might be reduced by the application of the biochar, rice husk biochar in this 3 bar to compare with just chemical fertilizer in the left 3 bars, or right 3 bars by using rice straw biochar. This is rice husk biochar in the middle, and to reduce the pH, to make it neutralize, because it's originally alkaline soil, so make it neutralize, and not a significant change for the EC. That is possible. And total carbon may be increased by using biochar, rice husk biochar. But sometimes the germination inhibited by maybe the water holding, but later on it can be overcome. We are a bit worried at the beginning, but the LPU people are also challenged to make it 100% biochar. That is not good, as you can see from this picture. So maybe maximum would be 25% in the biochar application. So the water holding capacity may be improved by these figures, and also the pH would be somehow improved, and EC is somehow trade-off. But the mineral nitrogen will be somehow like this one. Now all over the crop system, you can see the good harvesting, and also plant height and the stem also very good. And sometimes a drone picture like this one, another modern technique. Maybe you have already mastered how to utilize a drone. Before the harvest, you can see some good stand or bad stand. And also after chamber method, you can take the gas to see somehow the CO2 may be initially high as well as the methane, but it can be stabilized after 1 month or 2 months. Nitrous oxide somehow up and down, but later on this become better. We have some more data in for long-term measurement. And again, the CO2 equivalent can be shown like this one. CO2 is most dominant, and rice husk maybe somehow the optimum level may be different from the rice straw biochar. Nitrous oxide is not so significant, and methane is not the problem in this case. So in conclusion, somehow the biochar may be very effective for the greenhouse gas reduction, and pH can be improved. Total carbon may be also better for the carbon sequestration. Now another incubation study is ongoing to make it longer estimate for the greenhouse gas, and now result is coming out. As I mentioned, CO2 is somehow higher in the beginning, but later it stabilized. Methane sometime coming out, but the nitrous oxide also coming out. So be careful with the rice straw biochar. And also the carbon sequestration to make it CO2 equivalent to compare with total carbon and additional carbon. Maybe estimate for the total carbon budget that could be possible for the assessing a long-term effect. So in conclusion, as a take-home message, soil is an important natural resource, as you know well. Second, paddy soil can create greenhouse gas such as methane. Water control, however, can reduce methane and not increase the nitrous oxide if we carefully control. Soil carbon can be increased by biochar application. Soil CO2 production increased by biochar application can be balanced as a CO2 equivalent. Nitrous oxide was not so high, but in some cases in rice straw biochar, we should be careful. Trade-off the biochar application should be monitored in long term. Further experiments are also continuing. Okay, that's all. Thank you very much for your listening. Anyway,
Thank you so much,
sustainable
Professor
goal
Tomoshi.
for the soil is
so much.
important. Yes, 1, 2, 3 target, 12, 13, 15, every function is related to agriculture and soil. The no poverty, and the food security, and how to make it harmonize with land ecosystem and the healthy problem. So this is a part of Akash, as I mentioned, and thank you very much for all contributors, including some Japanese students. And now the end of my talk this year is the end of International Decay of Soil. You can see the earthworm here as a member of Healthy Soil. Thank you very much for your attention. Thank you.